Hi, this is Francis Sideco with TIRIAS Research. I'm here at Mobile World Congress 2024 with Ziad Asghar. He leads Qualcomm's AI efforts. So he's going to walk us through the booth and show us all the different AI innovations that they've been talking about. Not just even at this show, but pretty much on-device AI has been kind of a big messaging and positioning point for Qualcomm for the last probably 12 to 18 months, if not more. So go ahead, Ziad.
Perfect. Thank you. So again, we have been pushing the bar on what we can do with on-device, and this is a great next step that we have taken. This is a large language model, but it's very special. It's a multi-modal AI model, which means, for example, in this particular case, you can see you can take a picture, and what the model is able to do is you can ask it any question. For example, what are the ingredients that are going into this picture? It's able to tell you what the ingredients are. You can ask for a recipe that's based exactly on these ingredients, and it's actually able to tell you all the different kinds of things that you can make with these ingredients. But what does this really mean? See, now the input is actually an image, and output is actually text. So now we're getting to the point where we're just not doing text to text, we're actually able to understand what an image is doing. And I think that's really, really powerful. Let's take the example of taking something like this for a person that might be visually impaired. If you're a visually impaired person, this image can go into an AR-like device, and it's actually able to tell you what the person should be seeing in front of it. Amazing amount of capabilities that we can bring with devices like this. This is a 7 billion parameter model running entirely on the device without any assistant or help from the internet or from any other device. So very, very powerful capability for our models. This is one model that actually I talked about at the Tech Summit, if you remember. I said that we'll be bringing multimodality on, and you can see that just a few months after it, we already have it running. And really we have a bunch of new models that we're going to be bringing, and you'll see that I think what we are going to be able to do with our special hardware and software on the device, I don't think anybody else is going to be able to.
Well, it's amazing seeing this year, and I'm looking forward to all the other things we'll be seeing too, especially since this time last year we were barely just bringing stable diffusion at 1 billion parameters to the mobile device, and the amount of progress that we're seeing here going multimodal. I mean, obviously here on the input side it's multimodal. Is the output going to be multimodal as well, where you could go either, instead of just text output, have voice, or potentially even create, bring stable diffusion in, or Laura will be talking about that later, and have that be on the output.
Thinking about it the right way, right? So what this is showing is the first step in what multimodality will be able to do. Not only would you be able to do that, you could perhaps create new images from it. You could create 3D from it. You could create audio from it. Or you can also put like a text-to-speech interface on top of it, such that you're actually interacting with the model just by speech instead of having to type something. But that's absolutely in line with what we believe we can do with it.
So with this model right now, can you, aside from the image input, can you also do an audible input, like maybe like a song or something like that?
So you're thinking again on the right track.
Okay.
I'm going to actually show you a demo down there,
okay,
where we actually are going to be taking an audio input, and the model is actually able to make sense of what that audio has in it.
Perfect.
So absolutely in line with your idea over there.
Okay.
But see, this shows you the power of what on-device can do. As you bring in more modalities, it changes the experience of how we interact with that device.
Give us a little bit of a feel for what's the level of complexity multimodality introduces to the processing, and how you're having to deal with this.
Yeah, so when we are talking about large language models, we're primarily talking about models that are very much really memory bound. As in, what is one of the limitations for them is how much memory you have available, but the compute portion is not as binding. As you start to get to multimodality, these models are going to be compute bound and they're going to be memory bound. And I think that's where some of the special engines that we have created, like our Stellar NPU, really is going to shine even more compared to what people are seeing today, because now you have the complexity of compute and the complexity of memory as well.
So given that complexity, maybe one last question on this, given that complexity, is there any changes to the architecture, when you have these heterogeneous compute platforms, but you also almost need to have a heterogeneous memory platform where any of the processors are able to access maybe the same memory. I don't know. You tell me.
Yeah.
What are the impacts to the hierarchy potentially between, on the memory side?
The way we have created the AI engine on the devices, basically CPU, graphics, and our Hexagon NPU, all are engines that can actually do AI processing. Along with that, you also have the sensing hub, which allows you to do processing at a very low power consumption. The full memory access is available to all of these engines. And what we are able to do is to choose the right engine to be able to do for the right task for AI. And a model like this, which is very heavy and all, which will run much better on NPU, but there might be smaller models where you need very small latency, or might be much better suited to run on the CPU, for example. So we have provisioned the engine inside to be able to do all of that. From NPU specifically, since we knew that this trend was coming of large models and compute and memory requirements, we actually have sized it to be able to have the right tensor, vector, and the shared memory around it, along with transformer enhancements, like our special engine for transformer processing, to be able to make this the best engine for transformer and transformer-based models.
Perfect.
Yeah.
Thank you.